everyone, welcome to our YouTube channel. So in this video we are going to discuss one of the important concept of projectile motion, and it is a more standard form in JEE main, especially this particular case we can expect. So that's why I made a separate video focusing on this case. So in projectile motion, all we know that when we throw the particle with some initial velocity, here you can see we are throwing the particle with some initial velocity is u, then it has two components, that is u cos theta as horizontal component, u sin theta as vertical component. So as the particle travels, so here you can see that the different components of velocities are created. So and simultaneously the direction of instantaneous velocity also changes. So here you have to find out a particular time. So at what time you have to find out the particular time. At that time the instantaneous velocity and the initial velocity u, they both are going to be perpendicular. This case you have to calculate. Okay, to have this condition, how much time is required where our instantaneous velocity will be equal to will be perpendicular to the initial velocity, direction of initial velocity. Okay, so here you can clearly see that I have made this particular figure where we have initial velocity as u, and some after some time this instantaneous velocity we have from here is the instantaneous velocity is v, and if you extend the line of motion here, so you can see that they are making 90 degree to each other. So how much time it will take to make here 90 degree, let us see. So generally, if we write down the expression for initial velocity in vector form, you can write down initial velocity as u is equals to u cos theta I cap plus u sin theta j cap. This is our initial velocity. Okay, u cos theta I cap and u sin theta j cap. Similarly, final velocity if I write, then final velocity component I can write it as v vector equals to, so after some time the instantaneous velocity in x direction vx I cap plus in y direction let it be vy j cap. Okay, so similarly for Vx you can write down Vx equals to u plus at, since initial velocity along x-axis is ux plus acceleration along x-axis into t. So here you can see that the particle which is moving under this projectile or parabolic path experiences a acceleration due to gravity only in downward direction, that is along y-axis. So along x-axis acceleration is 0, along y-axis we have acceleration of g, or direction wise if you see minus g, in value wise you can write down. So here you can write down Vx is equals to since acceleration along x-axis is 0, ux equals to, you can write down u cos theta plus 0 into t, or here I can write down Vx is equals to u cos theta. Okay, this is the value of Vx. Okay, similarly here you can take velocity along y-axis, instantaneous velocity, that is uy plus acceleration along y-axis into t you can take. So it becomes u sin theta is the initial velocity along y-axis plus, here we have acceleration along y-axis is minus g into t, or you can write down u sin theta minus gt. Okay, this is our velocity along y-axis, here we can write down. Okay, clear? So now if I write down the instantaneous velocity taking Vx and Vy component, so here I will get a final expression of instantaneous velocity as V is equals to u cos theta I cap, that is the Vx, and Vy is we are getting u sin theta minus gt, and this is along j cap. Okay, this along j cap. So this is the instantaneous velocity. Clear? Now the thing is, if these two are perpendicular, which two, that is u vector and instantaneous velocity vector are perpendicular now, that means their dot product, when we do dot product, must be 0. Okay, when two vectors are perpendicular, then their dot product is 0. So here I can clearly write down u vector dot v vector equals to 0 in this case. So here we can write here u cos theta I cap plus u sin theta j cap, and we'll make dot product with u cos theta I cap plus u sin theta minus gt into j cap equals to 0. Okay, so now we have to perform this dot product. When you do this dot product, you'll simply multiply the I cap coefficient with I cap coefficient and j cap coefficient with the j cap coefficient. So here we can write down u cos theta into u cos theta, that is u square cos square theta plus u square sin square theta minus u sin theta into gt, the second component, which equals to 0. So on solving this, you can take this u square common from the first term and second term, cos square theta plus sin square theta you are getting, minus u, or you can write down equal to u sin theta into gt. And further solving this, this term becomes 1 here, so you can write down u square equals to u sin theta into gt, or here u square into u sin theta into gt. So this gives me that time equals to u square by u sin theta into g. Okay, further you can solve this one, u get cancelled, you can write down u cot theta, u cosec theta by g. So this much time is required to make the final velocity perpendicular with the initial velocity. Okay, thank you everyone.